So we're going to start our notes now in Chapter 7 for geometry, and this is going to be Lesson 7.1. Let me add that. And we're going to do a couple shorter notes on this one. And these are on dilations, and we've done these before. These are just transformations, where we either move a geometric shape or a line around in the coordinate plane. We make it bigger, we make it smaller. And here you can see the definition is a transformation that results in an enlargement or a reduction. Okay, and we have some important points here, and then we'll come back to what some of these letters mean here. Okay, so we have something called a center point, and that's a fixed point in the plane, and usually it's going to give you those. Sometimes they might even actually be in the figure itself, but then we use this center point to figure out and also construct our new figure that's either larger or smaller. And we call that C. Then we have something called a scale factor, and the letter they use for that is K, and K just refers to the amount the figure will be enlarged or reduced. We can know just by looking at this shape, or kind of looking at the rules, if K is greater than 1, it's an enlargement. If K is less than 1, it is a reduction. And if K is equal to 1, there's really no change. So we'll actually do that. No change. It's really the same size. Okay. So those are some important terms. Make sure you understand what center point means. And really, you could put a center point anywhere you want. I mean, you want to make it reasonable. But you know, if the scale factor is 1 and you put the center point here, you're still going to be measuring each vertices in the figure, and so it doesn't really matter where C is. It's not that important. Okay? So you're going to see some of your homework is going to have C, in a certain spot. But if you just do a general idea of writing it down, the figure, and then putting C relatively close to where it should be, you will be fine. Okay. So let's look at an example of this. And what you do with these is you take the center point, and J is going to be the center point on this. And I'm going to get a ruler. I'm going to pause here. And I'm going to get a ruler and kind of show you how to do this. So what you're going to do here is you're going to go from this center point, and you're going to draw lines to each vertices in the shape. And let's just call this a, let's say the K is equal to 2. Okay. So what we do is we go from each point, so J to K, and we're just going to draw a line, a jagged line that kind of tells us where it's going. Okay, there's J to K. Then we're going to do J to L, and do the jagged line. And then we get some pointer. Then we're going to do J to M. And then we're going to do J to N. Okay, so then we got that, and we're done. And we just follow along each one of these dotted dashed lines, and that will then tell us where the new point is. And we know the K, the ratio or the scale factor is 2, so we just measure from J to K. Let's see what we got here. Looks like 2.5, so 2.5 times 2 is going to be 5, so we're just going to place that right about there. I can see that actually. So we're going to so here's J to K, looks about 2.5, so we're just going to go to 5, and this is going to be our new K prime. We're then going to go from J to L, looks like it gives us about 4.5. So we're going to go to about 9. I'm going to go a little further here. Some of these are going to go into my writing, but that's fine. We're going to call this L prime. That's out there. So we got this one, we got this one. And then we're going to do JM. We do the measurement again here. So it looks like it's about 3.6. 3.6 times 2 is going to give us about 7.2. It's going to put us right about here. So we'll label that J prime. And then we got J to N. we're going to measure that. That's going to give us about, looks like 1.5 or 15. So we'll go to 3, and then that gives us n prime. Okay, so we have that one, which is right here. We have this one, j, which is right there. We have k, which is right there. And we have L, which is right there. So then we should just connect the lines to see what we got, see what it looks like. These may not always be perfect, so keep that in mind. Do your best to measure as you're going. That way it should be pretty close. We're going to go up to here. Maybe should have done this in a different color. Maybe I'll go back and do that. So let me just pause this here. I'm going to use different. Come back here. There's my original. Then if I have my new one, so it should be twice as large. And a way we could check and see if it's twice as large is we could measure these. So we see this side is 3. We look at this side, it's right about 6. We look at this side down here, we get about 2.5, a little less, about 2.4 actually, about 4.8 is about right. And we can just keep checking the size, but that's our dilation where we make it larger. That's kind of the process. And let me just show you one where I make it smaller. Let me get it set up. So if I'm doing a reduction, I am going to put my pencil here. Where'd it go? Good, over here. So I'm going to do a reduction. I'm just going to use a pen here. I don't make any mistakes. So again, I'm going to start with my center point, and let's just say my ratio is 1/2. Okay, and I would then draw these lines, right, just like I did with the other. Here's K, and I should remember, maybe put a point on that. I should remember it's going to come back, so I don't have to go beyond. It's going to get smaller. So in the end, my shapes are going to be back inside here. It's going to be smaller, kind of in here. It's going to be smaller. You'll see what I mean in a minute. And then I go to CL. Should lined up. There's that one. And then I go to CM. Okay. Then I'm going to measure what these distances are. So it's going to be, and we're going to make them half, right? Let's use centimeters, probably a little bit more accurate. So we're going to go, looks like this is 4.4, so we're going to go to about 2.2. So right about there. That is L prime. And then we're going to go CM. This looks like it's about 4.6. So 2.8. No, 4.6 would be 2.3. So about there. That would give me M. And then this one is going to be, it's 2, so it's going to give me 1 right about there. That's going to be my K. All right. And then if I just draw the lines, I'm going to do a different color this time. I'm going to do blue. And be careful with these. There's that. Mark it a little bit big, but I think it'll work. There's that. And there's that. So there's my half reduction. So then if I did this right, I should be able to compare. You know, it's a half of what the other one is, right? So I get about 4 there. And if I check this one, I should end up with about 2, and I do. And I check this one, it's about 3, and I check this one, it's about 1.5. And if I check the top one, it is about 2, and I should get about 1. So that looks pretty good. So those are examples of drawing dilutions. Just add these notes to your notebook, and I'll see you in class.